So I'm doing my presentation about the life cycle of stars, supernovas, and black holes. So when we think about these formations, we usually think that stars are really pretty twinkling dots in the sky, supernovas are really pretty cloud formations, and black holes just suck everything that is around. Even though the one that's like almost 100% true is black holes suck everything, supernovas are pretty cloud formation, but that's after an explosion, and stars aren't really tiny, they're pretty big. So the actual life cycle of a star, they all start as a nebula, which is a cloud of interstellar dust, helium, hydrogen, and plasma, and and then it starts forming into the protostar stage, which is the first stage of every star in its life. So that's when the gas in the dust um, is being pulled by gravity, and it starts getting hotter and denser, and that's what's called nuclear fusion. That's what creates the intense energy found in stars. And the life cycle really depends on the mass of a star. So if it's a small mass, it's protostar, main sequence, white dwarf, black dwarf. If it's medium, it's protostar, main sequence, red giant, white dwarf, black dwarf. And then large is protostar, main sequence, supergiant, supernova, and then out of the supernova, it can become a black hole or a neutron star. So, as you notice, that each, like, no matter the mass they go through, protostar and main sequence is the longest stage a star has to go through before it can, I guess you could say, excel. So a supernova is just a huge explosion after a huge, massive star used up all its fuel source, and it could choose between being a neutron star or a black hole. In a black hole, a lot of websites say that it starts its life with a death of a star because it is just a hole in space that the gravity is so heavy it sucks everything and light can't even escape. So, past, present, future information. Galileo, who was the first astronomer, used the new invention of the telescope to start looking at stars and start discovering how far they are, how close they are, what they do, like how they look like. And also, that was in the 1600s. And then Edmund Halley in 1718, he discovered the motion of stars of how they are in space. So, for present information, there aren't a lot of new discoveries because it takes so long to come up with anything. The only thing that NASA has really discovered is this new color of black that, when pointed at light with it, it sucks up 99% of the light. And it's the one it's like very similar black to the one in space. So for the future, there isn't any future information to go off of because it takes millions of years for anything new to come up in space because it's such a long process. So the relevancy to the world is that, like, with all this information, it's helped us figure out like how to calculate light years because they don't say, oh yeah, a star is like 5 miles away. Some of it's like, oh, that's like 3 light years away. So it's helped us expand our, I guess you could say, measurement calendar, like the measurement world, and also it's helped us with energy because the sun has its own energy, stars have their own energy. So we figured out how to, I guess, calculate their own energy to see how much. So that's it.